Hey there, tech freaks. You're back on the Tech Crux. Today, we're embarking on the third leg of our data science project, sentiment analysis. We've sifted through the web's vast ocean for precious data and prepared them to perfection. Now it's time to let NLP do the talking and discover which product wins the heart of our customers. So let's start with the question. What is sentiment analysis? Sentiment analysis helps us understand if a review is positive, negative, or neutral. It's like a compass that finds the direction of a person's feelings in their words. For this project, we will be importing some advanced libraries such as NLTK, which we saw in the last video as well. We have transformers and we have SciPy. So I'll start. The first step will be importing the libraries. Then we are importing the dataset, and this is the dataset that we prepared in the last video. You can compare it. There is no change in that. Then we have created a really great function here called calculate weighted score. This function assigns a weight to our three features that we'll be dealing with. So the three features that I've decided we'll be playing around with will be rating and review summary and review details. So you can see in the first step is we will be normalizing the rating. Since these two will get a numerical value using our models. For the rating we need a normalized value, so we normalize the rating first. Then you can see we run the model on review summary and review details. Both our models will give us three values: a positive score, a neutral score, and a negative score, and a compound score actually, which will be the average score. So the VADER model gives us four values while the ROBERTA gives us only three. It does not give us a compound score, so we'll have to create a function for that separately. We then calculate the weighted score for each sentiment using our weights. We have assigned a zero point 0.2 weight for the rating, zero point 0.3 for the summary, and the maximum weight for the details. Since details will contain the maximum amount of data, I felt it will be the best way to give review details the maximum weightage. So as I told you before, we are working with two great tools today, or I can say models, which is VADER and ROBERTA. So let's start with the VADER sentiment analysis first. We call our function here that calculates the VADER scores and creates new columns for it. So this is the sentiment intensity analyzer function that we are calling, and then we are using the polarity scores to get the sentiment analysis of any text. So suppose I've written the laptop is really cool and has a lot of cool and latest features. So it is saying it has a positive of 33%, neutral of 66%, and a compound of 66. So you can see it is a positive 66. So this compound tells me that it is a positive sentiment. So similarly, suppose we take the first index of our review details. So it says overall the product is really nice. Lenovo has included some tweaking features. There is a problem with Hinge, etc. So you see, it's not actually a totally positive review, but it's not also a 100% negative review. That's why you see the neutral having an 80%, while positive and negative having some less scores. So and you see the compound is really less. So here you see it was zero point 0.6, here you see it's zero point 0.1, because the model is not this statement itself is not either positive or towards very negative side. So we call our function here that calculates the VADER scores and creates new columns for it. Uh, you see we are creating columns for negative, neutral, positive, and compound scores. And then we are using the apply function, which is a really cool function to use that so that you don't have to loop over the data frame every time. And we're giving the arguments, and since it's multiple columns, we are using the result type as expand. So you see this is the data frame that we have now. We have added some extra columns for each review. We have a negative, neutral, positive, and a compound score. This data will be used for further analysis and eventually comparing the products and the reviews. We then create a blocks plot where for each product you can see the outliers as well as the mean values. So you see that for each product we have a box plot. It tells the distribution of the review of the score compound scores that we got from the VADER model, and this review is considered as an outlier. So here for this project we are not removing the outliers. We already have a small data set, so removing outliers will make it smaller. We can go ahead even with the outliers, I guess. So you see it's divided from what, zero point 0.1 to around zero point 0.5, and similarly you can see for each box plot how the distribution is, what's the compound score distribution is. Now enters Roberta. So VADER was a keyword based model which does not capture the context of the sentence. So here you see this sentence has good, cool, latest features. So these are all on positive note, and these, through these keywords it understands that it is a positive sentiment. But what Roberta does is it is our AI powered linguistic, which dives deep into the context and meaning of the sentences to find out the sentiment of our text. So here we are loading the Roberta model. So it will take some time to download when you will be running it for the first time, so be patient with it. Then we are using the tokenizer for the Roberta model, and then finally putting the model out there. So this was the result that we got from VADER, and if we do the same analysis using Roberta, so this is the result that we'll be getting using Roberta. So I'll print this. So these are the negative, neutral, and then the positive scores. So you see the Roberta model is quite confident that this is a positive review, and it also has some neutral values. So this review might not be the best way to show the capabilities of Roberta model, uh, since it is already a very questionable review. But let's try it with the example that we took with the VADER model. So for this, you can see that it is 98% sure that it is a positive sentiment. It's giving a 98, 0. It is giving a 0.98 score. And for the neutral and negative, it is way less. Whereas if we go to the VADER model, VADER gave a positive of 0.33 and neutral of 0.6. So that's the power of the Roberta model. So ROBERTA is a BERT model which is really powerful in sentiment analysis tasks. It is fine-tuned to perform sentiment analysis on Twitter tweets, so which are similar to the reviews. That's why we are using it here in our customer review analysis project. So at the end, you see that there is a softmax function which we are using to convert the raw scores that the model gives and into probabilities. So this is the probability of it being a positive, neutral, or negative score. You see that the Roberta model does not give us any compound score. So VADER gives us one simple score at the end which we can compare, but Roberta gives us three. So to compare them, we mix Roberta scores into one, just like VADER. So this way we can compare them directly. And after, so that's what I'm doing here, and I'm also adding a tag. Like here you see there are no tags. It's difficult to understand which is negative, neutral, or positive score. And then similar to VADER, we add these scores to our data frame and then generate a box plot of that. So for each review, you see now that, let me scroll it. So for each review, you see that we have Roberta negative, Roberta neutral, Roberta positive, and compound score. And we have VADER scores as well. So it's easier to compare the results of the model. And then coming on to the box plot, you see the box plot is shifted more towards the right, because if you analyze it yourself, you'll see the most of the reviews are on a positive note than the negative ones. So, and it is specifying there are more outliers than what VADER model said, and it looks like really confident in what it is showing. So you see there are accuracy greater than 80, there is positive tone greater than 80% in a lot of reviews, which we didn't see in the VADER model. So you can see from the box plot itself that there is a good amount of difference between the outputs of the two models. With box plots, we can see which products are getting all the love and which ones not so much. So let's compare these outputs and see the correlation between the results. Uh, so looking at the correlation matrix, we check how VADER and Roberta scores match up. Do they agree with each other or not? So for the VADER negative, you see there is a less score, and there are some distributions in some more scores than zero point 0.1 and zero point 0.2. For the neutral, it's distributed, but still it's in between, and positive is all over the place. But if you see the Roberta scores, it's really confident in what it is showing. So in the reviews that it is showing, it is showing high negative values, and for neutral it is showing the neutral, and then for the positive you see it's shifted towards the right. So negative shifted towards the left and positive towards the right. So this shows that our model is giving outputs very confidently. All these numbers and charts eventually lead us to one thing. They find the top product according to our customers. We aggregate first based on products and then combine the results to find out the best laptop ever, or at least from our dataset. So we first aggregate based on the product, and then we take the mean of the two values that we are getting, and then combine them and compare the best product. We get the maximum value using the ID max function and this is the product that shines out among the products that we fetched. So I think this is the first one itself. This has the combined score of 0.66, which you can see from the small data set that it is the greatest one. So you can replicate something like this in other projects, in some other use cases as well, where you have different types of metrics, different type of scores, and eventually you take an aggregate and then find out the best point in your dataset. And that's it, guys. This marks the end of our customer review analysis project. We've journeyed from the raw, uncut data to the polished gems of insights. It's been a ride of twists, turns, and tech where we learned whole process of a machine learning project using a simple use case. If you have enjoyed this adventure through reviews and sentiment, hit that like button and share with others, and don't forget to subscribe for more. We've got lots more to explore together. Keep learning, stay excited about data, and I'll see you in the next video. And remember, the best insights come from understanding the data we have, since data is always more important than the model. Thank you, guys.